Hello, grade 10 students. So this week we're going to continue our journey with optics. Today we're going to talk about the ray model of light. And in order to do this, there's some key things we need to understand about how light works. So the first thing is that all light is going to travel in a straight line. Okay, so all light is going to travel in a straight line here. Oops, that's not exactly what I meant to do, but that's cool. All right. Anything that gives light, so luminous objects that transmit light, so give off light, they actually do it in a whole bunch of different directions, okay? So if this is a candle, what you see and how the candle is able to emit so much light, like that glow, is because there's light rays that are transmitting off of it in all of these different directions. But notice that all of these light rays are straight lines. Some ideas or terms we need to know. The first one is what a light ray is. So a light ray is actually a line on a diagram that represents the direction and path that the light is traveling. And this is really important because we're going to talk about how different lenses and mirrors and all of those things work. And in order to do that, we need to understand how to draw them. So whenever we're talking about a light ray, we're talking about this line right here that's representing how that light is traveling. Geometric optics. So this is the use of light rays to determine how light behaves when it strikes an object. And this is really important. So for instance, I'm sure that you guys have heard all of this drama with the new Ontario license plates. So we need to understand how light is going to work when we hit those objects so that we can make sure that everything that we're using is safe and at full purpose. Incident light. So we're going to talk about these light diagrams, and our incident light is going to be that light that is coming off of the source as it's about to hit the object. So I also call that my incoming light ray, okay? So this is going into the diagram. Transparent. So remember that transparent is any material that's going to allow all of the light to go through it. So basically what that means is that it's going to transmit all or almost all incident lights, and we can actually see through these materials. So something like I almost said tinfoil, but that's not what I mean. Saran wrap, you can look right through saran wrap, which is great because if you're hunting around in your fridge, you want to know what to eat, you want to be able to look at it. Translucent. So translucent is any material that's only going to allow some of the light rays to go through them. All of the rest are actually absorbed into the material. And so this is something like waxed paper or parchment paper, where if you were to hold it up, you could see stuff behind it, but it's not fully translucent. Okay, you can only see a little bit of things through it. And then opaque is exactly like tinfoil, where now you're not going to transmit any of those light rays and nothing is reflected, or sorry, because they're either reflected or it's absorbed. So in the instance of aluminum foil, a lot of light is reflected off of that and we can see that, but you cannot see through that material at all. Okay. We need to talk about the idea of flat mirrors. So reflection is caused actually by by light bouncing off of a surface. And this is how we get that mirror effect. And specifically, mirrors work so well because they're a polished surface that allows this light to fluidly fluidly reflect off of it. So we can have a flat mirror like this, but this is also a plane mirror. So there's 3 planes of this mirror in which that we can shine light onto it. So that's why our light doesn't just bounce directly back at. So if this was my incident light ray right here, I'm shining the light towards the mirror, but notice that it's not directly reflected back. It's actually bouncing up. And that has to do with the mirror planes here. So in math, we know about the X and the Y axes, right? There's a third axis that goes through both of them called the Z axis. And this is what's allowing this bouncing motion to happen. Okay. And we're going to use the following symbols to represent a mirror in science because it's really hard to draw these things. So if this was the actual mirror, we're going to depict it by a straight line with these dashes. The straight line, that's going to be our reflective surface. The dashes, those are our opaque surfaces. Okay, so this is how we would expect you to be able to draw these using a ruler and with the dashes, and then you would label them, just so that we know. Here is the terminology of our reflection. So like I said, our incident ray is going to be that light ray. So this is our source of light. It's shining down. It's going to hit the normal, which is usually our mirror or our plane. The angle that the light ray makes between the incident ray and the normal is called our angle of incidence. After that, the light ray is going to bounce back, and this is where we are seeing the light, okay? So here, the angle between the reflected ray and our normal is the angle of reflection, and after, this is the reflected ray, okay? All right, that's it for today's lesson. There's some reading for you to do, very light work, so just take some time to read those textbook pages, and the next lesson is on its way.